Hello everyone, my name is Dan the Tutor. This is a clip from one of my weekly group tutoring sessions at the University of Delaware for Physics 201. If you have any questions, please leave them in the comments below. Thank you and enjoy.
We're going to start with conservation of momentum. Conservation of momentum. So what does that mean again? It means we're dealing with two or more objects. Let's say I have this 2 kilogram object sliding with a speed of 5 meters per second. That's going to ram into this bigger 4 kilogram box that, let's say, was at rest, v equals 0. These are going to collide. After the collision, the 2 kilogram box is going to ricochet backwards with a velocity of, let's say, 2 meters per second. And now this 4 kilogram box is going to be moving forward with an unknown velocity. That's what we're solving for in this problem. Okay, so we see the collision going on here. We see we have two objects, and we're talking about the velocities and the masses of both. This is so obviously conservation of momentum. Hopefully you can see that. Now, before I talk about the different kinds of collisions, elastic, inelastic, and perfectly inelastic, does anyone know what elastic means? Elastic. Anyone can shout it out.
I think it's when the two objects don't stick together.
That is true, but what is it called when they stick together? It has a special name. Anyone?
It's the completely inelastic.
Yeah, completely or perfectly inelastic. If you learned completely, then that's fine, obviously. Those objects stick together. Now, what's the difference between elastic and just regular inelastic? Elastic and inelastic. What's the difference? Oh, I should have wrote. Sorry. Completely inelastic. This is when the objects stick together. You know it when you see it. Okay, what's the difference between inelastic and elastic? Anyone know? Great. That's when energy and momentum are conserved. How do you know that happens in a problem? One of two things will happen. Either one, they'll tell you elastic, or two, you have to prove it. How would you prove it? Well, you need to say to yourself E total at point 1 equals E total at point 2, and you need to say P total initial equals P total final. If both of these are true, then it's elastic. And by the way, one thing I want to say is this right here, P total initial equals P total final, this is true for all collisions. Don't forget that. P total initial equals P total final. That's true for all collisions. Inelastic, elastic, completely inelastic. P total initial equals P total final. Again, as long as you're considering both objects. E total 1 equals E total 2, or I honestly should use better notation, because I usually pride myself with good notation. I should be saying E total initial and E total final, because just to keep it consistent. But in order to prove that, you need to ask yourself, well, what kind of energy do these blocks have? So just a quick talk about it. You don't have to write this down unless you really want to. What kind of energy do I have in this 2 kilogram block here? Well, I have a velocity, we see, so obviously it has kinetic energy, 1/2 mv squared. There's no height, there's no spring, it's just kinetic, and then the 4 kilogram block doesn't have any energy. I mean, yeah, it doesn't have energy because it's not moving. So the 2 kilogram block is the only one with energy. It would be 1/2 mv squared. 1/2 times 2 times 5 squared would be the energy initial. And then you'd find the energy final, which is, well, you look at the energy final here, but we don't even know the final velocity yet, so there's no point in talking about that. But just in general, if you want to prove that it's an elastic collision and they don't tell you, then you need to set the two equal to each other. Or, really, you need to see if they're equal to each other. Any questions on that? Elastic? The last case is inelastic. Inelastic. And this is easy because it just means only momentum is conserved. only momentum is conserved. This again comes back to the classic equation P total initial equals P total final. Okay, so that's it for the different kinds of collisions. Now, notice I didn't tell you what kind of collision this was, right? I didn't tell you if it was elastic or inelastic. So what should you do? Obviously, it's not completely inelastic because, well, they didn't stick together. So how do we know if it's inelastic or elastic, and does it matter? For the most part, no, it does not matter. And second of all, I would assume it's inelastic. I would assume energy is lost, and I'd have to prove myself otherwise. Again, it really doesn't matter, so let's just continue with this problem. I need to find this velocity right here at the end. How do I do that? Well, here's what I'm going to do. I'm going to say that P total initial, which again, remember, momentum P is equal to mass times velocity. P total initial is equal to mass times velocity 1 plus mass times velocity 2. Notice mass velocity 1 is my 2 kilogram object moving 5 meters per second. So mv1 is 2 kilograms times 5 meters per second plus my second object, which is a mass of 4 kilograms. That's not moving, so velocity is 0. So that means that P total initial is 10. And now again, I need to set that equal to P total final, which I need to solve right now. So P total final, this you can easily mess up. So I'm going to mess it up on purpose, and I want you to see how I mess it up. P total final, I look at my first object in the final case. This is the final case over here. I just circled it. Now I'm looking at the 2 kilogram object. I see that the 2 kilogram object has a mass of 2, and I said it's moving backwards with velocity 2, so times 2, plus my mass times velocity for the second object, again, 4 times an unknown velocity, v. You can call it v4 or v or whatever you want to call it. I'm just going to call it v because there's only one unknown velocity. Now again, I told you already I'm going to make a mistake. I did make a mistake on purpose. Does anyone see the mistake? This is not right. P total final is not right.
Would it be negative?
What's it?
The velocity.
The velocity for the first object is negative, so it doesn't matter which two, but one of these twos have to be negative. Why? Because momentum, it's so important that you remember that momentum, the direction matters, just like forces. Right is positive, left is negative. Of course, if you want, you can choose left to be negative and right to be positive. However, I feel like you're just shooting yourself in the foot there, and if you don't know what you're doing, then you're just going to lose. So, right is positive, left is negative, and just like that, now this is correct. So, again, we're saying these two things equal to each other. 10 equals 2 times negative 2 is negative 4, plus 4 times velocity. This will not be a round number, but it'll be close. Add 4 to both sides, you get 14 equals 4v. And then divide by 4. Velocity is going to equal, what, 3.5? 3.5, and the units for velocity is meters per second. Now, notice I got, oh, that kind of looks like an H. Hold on. That's supposed to be a 4. Sorry. 4v. Better. Okay. Notice 3.5. I got a positive final answer. What does that mean? What does that mean?
It's going to go in the right direction.
It's going to the right. If I got a negative final answer, it means it's going to the left. So notice for this problem, I told you that the bigger block is going to the right. I told you that from the beginning. I was nice. I didn't have to tell you that. You need to know how to find it, and it's all dependent on the final answer. A positive final answer is to the right. A negative final answer is to the left. If you want to make a note of that, I encourage you to, because it's important. Actually, one thing we can talk about, what kind of collision was this in the end of the day? Was it elastic? How would we prove that? That's a good question. Let's talk about it. So, E total 1, my energy at point 1, again, it was just the kinetic energy in that one block. So 1/2 times the mass, which you said was 2, times the initial velocity was 5, that's squared. The other energy was 0. Why? Because the 4 kilogram block was not moving. So this is going to simplify to, the 2's cancel, we get 25. E total 1 was 25. Now, energy total at point 2, it was going to be 1/2 times a mass of 2 times that velocity was negative 2 squared. Notice with energy, energy's nice, because even though it's a negative velocity, when we square it, that's going to become positive. So direction does not matter for energy. Direction matters for momentum and forces. So that's it for the first object. Then we need to add the energy of the second object, 1/2 times mass 4 times that velocity. We solved for it. It was 3.5. Square that. Energy total 2. Let's break out our calculators. 2 times 3.5 squared. Oh, this is funny. I love this example, actually. I'm glad this happened. 28.5 joules. Again, units for energy is joules. Now, what kind of scenario? What kind of collision was this? Was this elastic, inelastic, or completely inelastic? Anyone?
Is it inelastic?
It is, and the reason you said that, I'm assuming, is because these energies do not equal each other. If energy total 2 was 25, then yes, this would be elastic. But actually, another fun fact, this is also known as an impossible collision. This is literally impossible. Why? Because after your collision, you ended up with more energy than when you started. In other words, we accidentally created energy because I chose bad numbers. I do not expect this to happen where the final energy is greater than the initial. Again, it really doesn't matter, though. Because if the question is asking, is it elastic or inelastic, you don't care which one's bigger. You just care if they equal each other, right? So I wouldn't worry about that too much if you're confused by that. Okay, no more questions? We're going to move on to the last topic of tonight.
Don't forget to like and subscribe. If you want me to start doing free weekly group sessions at your university, please post in the comments below or email me at dan@danthetutor.com. Thanks everyone. Bye-bye.